Okay, I'm taking a risk here because I haven't worked this one out. So we'll see how many mistakes I make. So we are to determine IL of t, given that the switch was opened at t equals 0 after it had been closed for a long time. And we are given some information here. And I am going to work this in the S domain. It does not say to, and I think this one you could probably do either way. Alright, so the switch had been closed for a long time, so let's take a look at the state of things right before the switch is opened. Well, I see right away here we've got, if the switch had been closed, we've got a short right there, so nothing is going to go beyond this part. So the inductor will act as a short, but the current's never even going to get there because we have the short here in that branch instead. And the capacitor acts as an open circuit. Alright, so let's see. So all of the current is going to go through this branch. So IL of 0 is 0. Now we need to know IL of 0 and VC of 0 to cast it into the S domain, because if there is any current through the inductor or voltage across the capacitor, then that has to be accounted for. Note the capacitor is in parallel with a short circuit, and a short circuit has no voltage across it, so VC of 0 is also 0. So we have that. So now we can go ahead and redraw it in the S domain. So when I want to take the Laplace transform of everything, so the Laplace transform of 12 millivolts is going to be 12 milli is 0.012, and that will just be 0.012 over S. So that's what you get when you take the Laplace transform of a constant. R0 is 5 ohms. This switch now is going to be open, so I don't have that branch anymore. R1 is 10 ohms. The Laplace transform of an inductor is Ls. L is 0.2, so this is 0.2 S. R2 is 20 ohms. And the Laplace transform of a capacitor is 1 over SC. So that would be 1 over 0.006 S. Now let's figure out what 1 over 0.006 is. It is 166.7. So this is 166.7 over S. Okay, now I probably don't need to do this, but I'm just going to take a shortcut. So see how we have the 5 and the 10 ohm that are in series. Let's just replace those with one 15 ohm resistor. And now it looks like this is, remember my S's look like 5, so be careful about that. This looks like it is well set up for a nodal analysis, which I love. So I'll put a V there, and I'll make this ground. So going in this direction, V minus 15, nope. V minus 0.012 over S all over 15. plus, going down, V minus 0 over 0.2S, plus, going to the right. Now, remember that in the S domain, everything acts like resistors. So this 20 ohm resistor and the capacitor in series, those are, I can just add those together as if they are resistors. So if I wanted to, I could actually redraw this circuit like this. And this over here, what I have as a resistor over on the right, that's just going to be the sum of my 20 ohm resistor and the 166.7 over S, because they were in series. Okay, so we got the current going in this direction, we got the current going in this direction, and now the current going to the right is V minus 0 over 20 plus 166.7 over S, and this whole thing equals 0. Oh, I didn't know that I was recording through all that. I'm sorry. Yeah. And I don't ever go back and edit things out, so I guess you just got a whole lot of, like, I doing nothing. Alright, so now let's simplify this a little bit. I'm going to multiply this equation by this fraction by s over s, and also this fraction here at the end by s over s. And that will give us vs minus 0.012 over 15s equals v over 0.2s plus vs over 20s plus 166.7 equals 0. This was a plus, so I don't know why I put in equals. Okay, so now my computer is messing up. My mouse keeps going out on me, and I'm gonna have to, as soon as I finish this recording, I'm gonna restart. So this is will be made easier when our coefficients on the bottom are all 1. So just rewrite this first one as 1/15 vs minus 0.012 over s plus 1 over 0.2 v over s plus 1 over 20 vs over s. Maybe it's my pen that's causing problems. S plus, now I factored out a 20, so I need to divide that 166.7 by 20. 8.335. Alright, 1/15 is 0.0667, so I can write this top one as 0.0667 times vs minus 0.012 over s. And 1 divided by 0.2 is 5, so plus 5v over s plus 1 divided by 20 should be what is that, 5 over 100.05. So 1 divided by 0.05, so 0.05 vs over s plus 8.335. Okay, so our common denominator equals 0. Okay, so our common denominator is s times s plus 8.335. So this is, the numerator is 0.0667. Okay, yeah. I told you that this I was going to mess up, and I did. So, not too bad yet. So before I did this step that I'm doing right here, what I want to do is I want to get everything that doesn't have a V over to the other side. What I really want to do is to get my pen working and my computer. So I am going to on this from here to here, I'm going to break this fraction up. I'm going to take my VS minus 0.012 over 15S and break that up into two fractions, VS over 15S minus 0.012 over 15S. And then I can take the 0.012 over 15S to the other side. And so what I will have here, so this, let's just leave that 15 there for now. So what I'm going to do, I broke this up into two pieces, and I'm going to take this to the other side. I'll add it, so plus that to both sides. So on this side I have 0.012 over 15S. Okay, so that means that what I have in the numerator here is really just 0.667 VS. And then when I get my common denominator, I multiplied that by S plus 8.335. Now my second fraction here, 5V, I'll multiply that by S plus 0.8 or S plus 8.335. All that over S times S plus 8.335. And this last fraction, I need to multiply that by S. So I get 0.05 VS squared over S times S plus 8.335. And that equals, now remember the 1 over 15 was 0.0667, so I can multiply the 0.0667 by the 0.012. .0008004 over S, because I brought that 15 up. 0008004. 0008004. Yep. Okay, so now I factor a V out of everything. And I have 0.0067 S times S plus 8.335 plus 5 S plus 8.335 plus 0.05 S squared all over S times S plus 8.335, and that equals 0.008004 over S. Okay, so I've restarted the computer, so maybe things will work a little better. Alright, so now let's see if we can do our simplification up on top. So this is 0.06. This is supposed to be 0.0667s. So 0.0667s times s is 0.0667s squared. And then I also have a 0.05s squared right there. And then I have a 0.0667 s times 8.335. And that's 0.556. S from that s. And then I also have a plus 5s right here. And then I have a 5 times an 8.335. Is 41.675. All that over s times s. Plus 8.335 equals 0.008004 over s. I'm a little worried about that number. It seems awfully small. Alright, so now that's 0.1167 s squared plus 5.556 s plus 41.675 all over s times s plus 8.335 equals 0.008004 over s. Now, if there's like there is no chance that I have not made some arithmetic mistakes in here, because that's just what I do, and there are too many places for me to have made them. But now what we do is we divide both sides by this whole thing right here so that we get v by itself. So I have v equals 0.008004 times, where did that small number come from in the first place? That was the 0.012 divided by 15. Which I got. Okay, so that's really should just be 0.0008. Oh, just 3 O's? Yeah, 3 O's and an 8, so we don't need to worry about the 4, but still, okay. Alright, so 0.0008 over s times s plus 8.335 over 0.1167 s squared plus 5.556 s plus 41.675 and then I would want to factor out. Okay, I'm just kind of miserable because everything keeps messing up. This was plus 41.675. I don't know where that went to. I found another pin. Let's see if that makes any difference. Now I want to factor out this 0.1167. So I want to have, let's see if I can fold this back. So I will have 0.0008 over 0.1167s, and then I have s times s plus 8.335 over s squared plus, now I'll take 5.566 whatever. 5.556